Welcome, future space explorers, to a journey beyond our wildest dreams. We're on the brink of a new golden age of space travel, and the technologies powering this revolution are straight out of science fiction. Today, we're counting down the top 12 new spacecraft technologies you absolutely have to see. Forget what you think you know about space, because the game is changing faster than a rocket launch. From engines that could take us to Mars in mere weeks, to materials that can heal themselves in the harsh vacuum of space, we're about to unveil the innovations that will define humanity's future among the stars. So, buckle up, hit that subscribe button, and let's blast off into the future. Starting our countdown at number 12 is something that sounds simple but is incredibly complex. Advanced life support systems. Imagine living in a sealed can for months, or even years. The International Space Station has a good system, but future long-duration missions to Mars and beyond need something better. We're talking about closed-loop systems that recycle nearly 100% of all air and water. Think of it as creating a mini-Earth inside a spaceship. Scientists are using algae and advanced chemical processes to turn astronauts' breath, sweat, and waste back into pure oxygen and clean drinking water. This isn't just about saving weight on launch. It's about making humans truly independent from Earth, a critical step for becoming a multiplanetary species. Coming in at number 11, we have self-healing materials. Space is an incredibly hostile environment. Micrometeoroids, tiny bits of rock and debris, are traveling at speeds over 17,000 miles per hour. A tiny impact can cause a catastrophic hull breach. The solution? Materials that can patch themselves up? Researchers are developing smart materials, often polymers, with embedded microcapsules. When a crack forms, these capsules rupture, releasing a healing agent that fills the void and hardens, sealing the breach instantly. This technology is like giving our spacecraft a biological immune system, dramatically increasing the safety and lifespan of missions far from any repair depot. It's a quiet revolution in spacecraft durability. At number 10, we're talking about a game changer for building big things in space manufacturing and 3D printing. Why launch a massive fully assembled satellite when you can just launch the raw materials and print it in orbit? Companies are already testing 3D printers on the ISS to create tools and spare parts on demand. The next step is even bigger. Imagine robotic arms extruding massive trusses, antennas, and even entire habitats right there in the vacuum of space. This reduces launch costs, bypasses the size limitations of rocket fairings, and allows for designs that would be impossible to launch from Earth. We could build space stations the size of cities, or telescopes with mirrors kilometers wide. Our number 9 spot goes to something that will redefine how we navigate the cosmos. Deep space atomic clocks. When you're trying to land a rover on Mars, timing is everything. A tiny error can mean the difference between a perfect landing and a very expensive crater. Currently, spacecraft rely on a constant two-way conversation with Earth, using massive ground-based atomic clocks to pinpoint their location. This creates delays and bottlenecks. NASA's Deep Space Atomic Clock is a miniaturized, ultra-precise timekeeper, about the size of a toaster, that can be placed on the spacecraft itself. It's 50 times more stable than the clocks on GPS satellites, allowing a spacecraft to calculate its own trajectory in real time. This autonomous navigation is essential for crewed missions to deep space where communication delays are a real problem. Blasting into number 8, we have next-generation spacesuits. The suits worn by Apollo astronauts were marvels of their time, but they were bulky and restrictive. The future of extravehicular activity, or spacewalks, requires suits that are more like a second skin. Engineers are designing suits with enhanced mobility, using flexible joints and lighter materials. They're also integrating augmented reality displays right into the helmet visor. An astronaut on Mars could see vital signs, geological data, and instructions overlaid directly onto their view of the landscape. They'll have better dust protection, advanced temperature regulation, and even self-healing capabilities. These aren't just clothes, they're personalized spaceships for one. Number 7. We have a technology that will help us explore worlds we've only dreamed of. Cryogenic fluid management. The most powerful rocket fuels, like liquid hydrogen and liquid oxygen, are also the coldest. They have a nasty habit of boiling off into space over time, which is a huge problem for long missions. You can't just top up the tank on the way to Jupiter. New technologies involve creating zero boil-off tanks. This uses advanced insulation, like multi-layer blankets, and super-efficient cryocoolers basically. Incredibly powerful refrigerators to keep the propellants in their liquid state indefinitely. Mastering this technology is the key to unlocking the entire outer solar system for ambitious missions. Halfway through our list at number 6 is a truly mind-bending concept. Solar sails. Forget rockets and fuel entirely. Imagine a spacecraft pushed through the cosmos by nothing but sunlight. Solar sails are massive, ultra-thin sheets of reflective material, thinner than a human hair but stretching for hundreds of meters. Photons, the particles of light from the sun, have no mass, but they have momentum. As they bounce off the sail, they give it a tiny, continuous push. It's a small push, but over weeks and months in the frictionless environment of space, a solar sail can accelerate a craft to incredible speeds. It has the ultimate in fuel efficiency and could be perfect for sending probes to other stars over long timescales. Breaking into the top 5 is laser communications. For decades, we've relied on radio waves to talk to our spacecraft. It works, but the data rates are painfully slow. Trying to stream high-definition video from Mars over radio is like trying to fill a swimming pool with an eyedropper. The solution is using lasers. By encoding data in beams of light, we can increase bandwidth by 10 to 100 times. This means we can get more science, data, higher resolution images, and even stream live 4,000 video from the Moon or Mars. NASA's Psyche mission is already demonstrating this capability. Faster communication isn't just a convenience, it's a necessity for coordinating complex, robotic, and human operations across the solar system. At number 4, we have something that will protect our astronauts on their long journeys. Advanced radiation shielding. Outside of Earth's protective magnetic field, space is flooded with dangerous radiation from the Sun and deep space. A trip to Mars could expose astronauts to a lifetime's worth of radiation in just a few months, dramatically increasing their cancer risk. New shielding concepts are moving beyond simple thick layers of aluminum. One promising idea is active shielding, which generates a powerful magnetic field around the spacecraft to deflect incoming charged particles, mimicking Earth's own magnetosphere. Other concepts involve using materials rich in hydrogen, like special plastics or even water, which are surprisingly effective at blocking radiation. Our number 3 spot goes to a propulsion system that is already powering missions and is getting more powerful every year: ion propulsion. Instead of a loud, violent chemical explosion, ion thrusters use electricity, often from solar panels, to accelerate charged particles, or ions, of a gas like xenon. The thrust is incredibly gentle, about the force of a piece of paper resting on your hand. But the key is its efficiency. An ion engine can run continuously for years, slowly but surely building up tremendous velocity. It sips fuel instead of gulping it. NASA's Dawn mission used ion thrusters to orbit 2 different asteroids, a feat impossible with chemical rockets. The next generation of these engines will be more powerful, enabling faster transit for robotic cargo missions to Mars. The runner-up, at number 2, is nuclear thermal propulsion. This is where things get really fast. A nuclear thermal rocket uses a small nuclear reactor to heat a propellant, like liquid hydrogen, to extreme temperatures, then expels it through a nozzle to create massive thrust. It's far more efficient than the best chemical rockets. While a chemical rocket trip to Mars could take 7 to 9 months, a nuclear thermal rocket could cut that travel time down to just 3 to 4 months. This is a huge deal. It drastically reduces the crew's exposure to radiation and the psychological strains of deep space travel, making a human mission to Mars safer and more feasible. It's the workhorse engine that could open up the solar system. And now, the number 1 new spacecraft technology you must see. The one that could truly change everything is fusion propulsion. This is the holy grail. Fusion is the same process that powers the sun, smashing light atoms together to release immense energy. A fusion rocket would be orders of magnitude more powerful and efficient than any other system we've EVA discussed. We're talking about trips to Mars in a matter of weeks, not months. Jupiter in less than a year. A fusion-powered starship could even reach speeds that make interstellar travel a realistic possibility within a human lifetime. While full-on fusion power is still in development, several companies and labs are making real progress on concepts like direct fusion drive. It's the ultimate leap, promising to turn humanity from a planetary species into a truly interstellar one. From self-healing holes to starships powered by artificial suns, the future of space exploration is brighter and more exciting than ever. These 12 technologies are the building blocks for our next great adventure. Which one are you most excited about? Let me know in the comments below. Thanks for watching, and don't forget to like and subscribe for more journeys into the future. See you next time.